Here we create a new playlist instance, add 5 songs into it that will have incrementally created IDs. Next we print them, then we remove the song with ID number 2. A linked list is a type of data structure that consists of a sequence of elements where each element is stored in a node. Each node contains two parts: data, the value of the element, and pointer, which is the reference to the next node in the list. In a linked list, nodes are connected one after another, forming a chain or a list. The first node is called the head, and it links to the next node, which links to the next one, and so on until the last node, which points to null, indicating to the end of the list. Think of a train with multiple cars connected one after another. Each train car represents the data. Each train car has a coupler connected to the next car, which is the pointer to the next node. The first car in the train is the head in the linked list, and it's the starting point of the train. The last car is not connected to any other car, making it the end of the train, which is the null pointer. If a car is removed, you just disconnect it from the train, and the cars on either side linked directly to each other. Unlike arrays, linked lists don't need all their elements to be sorted in contiguous memory. Each node is independent, and the pointer connects them in a sequence. You can add, remove elements at any point in a linked list without shifting as you would in an array. This makes linked lists useful for applications where data is frequently inserted or deleted. To see how linked lists could be used in real-world applications, we are going to build a music playlist in a JavaScript, where each song can be added, removed without restructuring everything. Each song is a node in the list and will contain title, artist, and we will add a dynamic ID that will be auto-incremented just for the demo purpose. And also it will have a pointer to the next song. First, we will start by defining a song node class. This is the blueprint for each song in our playlist. There is the current ID, which is the static property, which means it's shared across all instances of song node. We will use this to give each song a unique ID by incrementing the value every time we create a new song. Then in our constructor, which is the initializer, it accepts two parameters, the title and the artist. Finally, we add the next property. Initially, the next is set to null because we haven't linked this song to any others yet. Now let's define the playlist class, which will let us add, remove, and display songs. The head property represents the first song in our playlist. Initially, it's null because our playlist is empty when we start. Next, we will define three methods. The first one will be add method to add songs to the playlist. Here we will create a new instance of the song node that we just created with a given title and artist. This song will be added to the end of our list. Now we check if the head is null, meaning the playlist is empty. Then we will set the head to the new song that we just created, making it the first item in our list. Otherwise, we need to traverse to the end of the list. We start by setting the current pointer to the head of the list, and we will define a while loop that will moves the current to the last song in our playlist by following each song's next pointer until the next pointer is null. Finally, we link the last song to our new song by setting the current next to the new song that we just created. The next method, which is remove, which lets us delete a song based on its ID. We will check if there is no head in our list, which is null, then we exit as soon as we can. If the song to be removed is the first song in the list, we update the head to the next song. If the song to remove is in the head, we set current to the head of the list and we start searching for the song to remove. In this loop, we look ahead to the next song. We keep moving the current forward until we find the song with the matching ID. If we found the song to remove, we skip over the current next to the current next, which removes the song from the list without breaking the chain. The final method will be show all for the demo purpose, which displays all the songs in our playlist. Here we create a new playlist instance, add 5 songs into it that will have incrementally created IDs. Next we print them, then we remove the song with ID number 2. Finally, we print the updated list showing the remaining songs in the list. And that's it. This is how you can manage a playlist with basic add, remove, and show functionality using a linked list in JavaScript. Thanks for watching and don't forget to like and subscribe.